Hey guys, welcome back. In this video, we're going to do the questions that I assigned. There's a mixture of everything between power rule, product rule, quotient rule, implicit differentiation, and chain rule. So in this video, I'll do the first 4 problems that I assigned. In the next video, I'll do the next 4 and so on. Okay, the first problem was 2x to the third minus 1 over x squared. It almost looks like it's a quotient because there's an x in the numerator and there's an x in the denominator, but it's not a quotient because the x in the denominator is a monomial. You could use a quotient rule, but it's silly to do that. What you should do is split them up. Do 2x to the third over x squared minus 1 over x squared. X to the third over x squared is x to the first, because when we divide, we subtract the exponents. And then we have 1 over x squared. We're almost ready to take the derivative, but not yet because I still have this guy right here. So I'm going to rewrite him as 1x to the negative 2. Now be very careful when you do the power rule with negative exponents. I'm ready to take the derivative, so I'm going to denote it by y prime. The derivative of 2x is 1 times 2 is 2, drop the exponent by 1. And then negative 2 times negative 1 is going to be a positive 2x, drop the exponent by 1. We know that x to the 0 power is just 1, so this is 2. We know 2 stays in the numerator as x to the third, to the negative third, becomes now a fraction with x to the third as the denominator. You can leave your answer like this. If you choose to combine fractions, which you don't have to, you'll get 2x to the third plus 2 over x to the third. So check your answers. So that's how you do the first one. The second one is y equals 3x times tan of 5x. Now this is a product rule because I see there's an x right there and there's an x right there. So I actually wrote them in different colors. So when I perform the product rule, I can say to myself, keep the first guy, which is 3x. Now I'm going to take the derivative of tan 5x. Now the derivative of tan angle is secant squared angle, always times the derivative of the angle. Okay, so that's the first part. I kept the first, I took the derivative of tan angle. Derivative of tan is powerful, so it's secant squared angle times the derivative of the angle. Now we have to do it the other way. Plus, let me grab a different color. Plus, keep the second just the way it is, times the derivative of the first. The derivative of 3x is just 3. Now we know we can't times angles and these coefficients, so I'm just going to clean this up just a little bit. Plus 3 tan 5x. So that's your final answer. If I'm going too fast, pause the video, rewind the video, watch it again and again until you get it perfect. So this is the product rule. The product rule says keep the first derivative of the second plus keep the second derivative of the first. Third one. The third question is a quotient rule. Now I don't have a monomial in the denominator, so I must use the quotient rule. Some people may say, can I use the chain rule? But I wouldn't recommend the chain rule for this. So what does the quotient rule say? It says keep the bottom derivative of the top. The derivative of x is just 1. Minus keep the top, the derivative of the bottom. Now I'm going to show you what the bottom part looks like. Okay? It looks like this. So what does that tell us to do? Well, that is a chain rule, and the derivative of that guy is, if you remember from my chain rule videos, it's just like the power rule. So it's 1/2, recopy the inside, decrease the exponent by 1, so it becomes negative 1/2, times the derivative of the inside. The derivative of x squared plus 1 is just 2x. What we notice here is that 1/2 and 2 cancel each other out because 1/2 of 2 is just 1. And now the derivative of the bottom, so I kept the, if you remind yourself, keep the bottom derivative of the top minus keep the top. Now I'm going to do the derivative of the bottom. And the derivative of the bottom is going to be x from this person here over square root of x squared plus 1. Why? Because x squared plus 1 to the half is a square root. Negative means put me in the denominator. So I kept the bottom derivative of the top minus keep the top derivative of the bottom all over the bottom squared. Well, if you remember, squares and square roots cancel each other out. So this guy right there cancels out. So how do I clean up the top? And should I clean up the top? Absolutely. The top gets cleaned up by finding a common denominator. The common denominator is x squared plus 1 square rooted. Okay? And you can crisscross tomato sauce if you want to, or you could just say, I'm going to find the common denominator. That gives you x squared plus 1 from the top, and then minus x squared, all over x squared plus 1 square rooted, and that is all divided by x squared plus 1, which is this person here. Now, we notice that the x squared and the minus x squared goes out, and if you guys do keep, change, flip, you'll notice that it would be this here. So work out the math by yourself. The hardest part was the derivative of this chain rule, but that's also easy. Combine fractions to make a single, and that's that. So this is your answer. And finally, number 4 is implicit differentiation. In order to find dy dx, what you're going to have to do is every letter other than a x, you're going to have to go d the letter dx after you take the derivative of it. So this person here is 3x squared, okay? This person here is 0. This person here is 3y squared, but because it's a letter other than x, it's dy dx. Now the middle part is a product rule. So the product rule is I'm going to keep the minus 2 out. I'm going to keep the first. Derivative of y is dy dx, plus keep the second. The derivative of x is 1. Okay? And now you're just about done. You just have to clean this up to solve for dy dx. And that's going to be pretty simple. Anyone who doesn't have a dy dx stays on the left side until the very end. So these two people stay here. And we're going to bring that as a positive 2y and that as a negative 3x. So positive 2y, negative 3x squared. And then we're going to have negative 2x dy dx. And we're going to have positive 3y squared dy dx. And then we're going to factor out the dy dx, right? Because that's how we're going to solve for it. And then you're just going to divide. And your answer is going to be 2y minus 3x squared divided by negative 2x plus 3y squared. Sometimes in mathematics, we like to write the negatives after the positive. So you can rewrite that as 3y squared minus 2x on the denominator. Okay, so come back for the next 4 questions.